Hi guys. So quick update. Been doing some digging on their Grober drug, the one that failed for spinal muscular atrophy. Uh, Quick reminder: it is basically it's the anti-myostatin annexin, and it forms a complex with a bunch of other myostatins, and I believe it's two other myostatins. So not only does it take myostatin um, out of the system, it also by binding it, this complex can then also go on uh, to uh, to bind to, I believe it's um, activin 2B. So activin 2B receptors in muscle cells, um, which also prevents um, prevents a myostatin to binding to these cells, i.e., causing hypertrophy. Right. So, in terms of obesity, um, I think their motivation for this came from the fact that there was a considerably well a very strong evidence that overall body mass decreased during during the Resilient trial, the trial that they did for SMA, the one which failed on the primary endpoint, but it did show um, a reduction in overall body fat mass with a really convincing p factor um, in this SMA trial, right? But then the key question becomes, sure, this happened, but SMA is not really representative of the obese population, right, in the US or in the world that would actually need this drug for weight loss, right? And I basically did some digging. They had they have a lot of material on this, and to kind of sum it up, they did a bunch of mouse tests, mouse models, and in these mouse models, it showed uh, they showed incredible fat loss, body fat mass decrease, whilst increasing lean mass, right? So, well, not increasing lean mass, but increasing um, muscle mass. And these things they looked incredibly promising. But basically, I think you can put it all down to the actual intended effect that they wanted it to have in this trial, right? Which is that it's leading to muscle growth, and muscle growth is causing this kind of rapid muscle growth is causing a a caloric deficit, which is then um, you know um, resulting in reduced body fat mass, right? Because the mouses are using up body fat to convert it into muscle. The only problem is that um, a mouse's you know physiology lends itself to um, this kind of fat reduction much more so than humans, and there have been there have been significant studies in the past uh, that try a similar kind of method of action. Um, One of them, I think, was it was like let me have a look. What was it called? Some sort of mab. Basically, it was a an antibody that prevented activin 2B dimerization. But I'm looking. Yeah, no, I can't remember what it was called. But here it is. No. Okay, never mind. Anyways, so it basically showed a very kind of limited um, use case for obesity. If anything, I think this could probably be an adjunct to GLP, but there's no way that this is going to be. There's no way in my mind, I don't think. Well, it's very, very unlikely, unless there's some sort of mechanism going on here that is not yet well understood um, in medical literature as to how this thing is causing liposis and brown fat thermogenesis. I mean, it's just very unlikely. So the reason for that, well, anyway, so the point about these other drugs that are similar to it is that they basically didn't. Well, they're all in kind of development at the moment, but none of them are in development as standalone treatments for obesity, and many of them that have similar methods of actions are in development not for obesity, but for all sorts of other diseases. Right. So they plan to initiate. So they had this positive readout, and they got very excited. Right. So they wanted to initiate in Q224. My theory is that actually, and this is probably not very good for Biohaven, at least on this front, is that they came to the same conclusion that I've come to, and they realized that this is probably a dead end, so they decided to look at something else and kind of focus on some other stuff. That's just a theory. There's no reason why that has to be the case, but they claimed that they were going to start their clinical trial in the fourth quarter. They didn't actually start it until the third quarter of 2024, so that's almost like a year delay between the idea to do the phase 2, the actually starting it. Yeah, so basically, the body composition of SMA patients is much different. So they have a much higher metabolic rate, metabolic response, because of their generally lower body mass, and this of course means that small changes in muscle mass can cause large metabolic changes, which in turn causes relatively higher rates of lipogenesis. So the SMA patients also are not only do they have faster, are likely to have faster liposis than obese individuals without SMA, but also so that's something that is likely to skew the results in the favor of body fat mass loss. But also they have a much higher relative fat mass. It's even than obese patients, and this isn't actually a good thing because a much smaller loss in absolute fat can actually be statistically significant, right? Because their overall, as an overall percentage of their body fat, is much greater, whereas it's quite likely that in somebody who has a much greater overall fat mass than these SMA patients, this same Taldefibril drug is going to have a similar absolute fat loss effect as these SMA patients, which is of course a much smaller objective result and is much less significant, and perhaps even if it is statistically separates, so even if it statistically separates, the actual effective fat loss is going to be much, 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 much less than standard weight loss drugs being used at the moment. So we're looking at, maybe in the range of 2, 3, 5% over several months versus, 20, 30% with like Wegovy and Ozempic. So that's also no good. Mouse models are not accurate for human in vivo pharmacodynamics. For the reasons that I mentioned, they're much smaller, they have much higher lipolytic sensitivity. Yeah, and it's very unlikely that the in vitro study with human cells, the in vitro study will translate. And basically, they had an in vitro study where they looked at they compared a case study. They compared basically activation of I forget the name. It was something like something beta. It's the thing responsible for initiating creation of fat in the body, and they had two separate studies, one in which they put activin 2B, which of course showed increase in the activation of this substance. One second, let me just get it up so that I'm not talking absolute nonsense. I can actually find you the specific substance. Bear with me a moment. Publications, Talif-Groby. Here we go. Yeah, beta-gal substrate, right? So that's what it is. Beta-gal substrate. And when activin binds to the ACT-RIB ALK7, mouthful, gate, it causes this substrate to be activated, which then in turn causes all sorts of kind of fat cells to be at least maintained. Anyway, it makes you fat, okay? Jesus. And they compared that with a study where they put let me get this actually. Let me get this. This is probably, if I get this as a perhaps this is clearer for you. So yeah, basically the whole mechanism for lipolysis, right? So they're arguing in this trial that in fact, no, the fat loss that we observed in these SMA patients and the fat loss that we have observed in mice in vivo studies are um, are because of this mechanism here, right? So they're because of actual lipolysis and thermogenesis, not because of increased caloric requirements and due to increased muscle mass, right? So they're arguing that it's because of this mechanism as well. But the issue with this is that in the actual trial for which they're trying to, so this is they're trying to show that this beta gal signal is significantly reduced when they introduce myostatin into this Tavgrobi alpha and activin solution. That, of course, this myostatin binds, right? So it binds to the Tavgrobi, creating this myostatin complex, which in turn can then go and bind to these receptors. Of course, we have a lot of floating T alpha, but T alpha is just this bit. So that's over here, right? We have 1 microliter of T alpha, but no myostatin to bind to it. And bear this in mind because this is actually key for later. Once we increase the myostatin concentration, we can create this complex, which then in turn shows that in the limit where myostatin concentration approaches translates alpha concentration, right? So there are more and more and more in the limit that all of my myostatin, and there's an excess of this complex in the solution, then the beta gal signal is reduced, right? And this is all fantastic. The only thing you have to bear in mind is that actually their activin B tetralestinidazomycin. So the volumetric ratio, the mass ratio, the number ratio of activin to myostatin is like 1000x here, right? This is a nano. This is a nano and this is a micron. That's 1000x, right? So for this to occur, and for you to meaningfully move away from activin B being the dominating thing that binds to the ACT RIBA-ALK7, you need like 1000x. Okay, sure, maybe not 1000x, because you could argue, okay, 50%. If we're signaling by less than 50%, that's great. But again, I guess I should look into, how much does this signaling need to reduce, this beta gal substrate signaling need to reduce for it to result in, meaningful fat reduction. But I'm not convinced that it will be particularly meaningful, and maybe it is. But I'm kind of done beating this obesity dead horse here. If it works, it works. I think there's maybe about a 1% chance, 2% chance that this actually, works, and it shows it meets the primary, secondary endpoint or any of them. I really don't think it's likely, because this 1000x concentration gradient here and even a 100x concentration gradient is basically impossible in vivo, in humans, because number one, myostatin is a hard upper limit, right? So even you can take all the tenosynoids alpha you want, but myostatin, if you have a look at that, then you can look up various numbers, but from what I gathered, it was really nowhere near the ratio. The ratio of myostatin to activin was nowhere near the ratios required for this to have a, meaningful decrease. That's not the only thing that they quote, of course. They talk about the decrease in phosphosmad 2,3 signaling in adipocytes in a mouse model and in a human model in the presence of myostatin and tenosynoids alpha. But it's sort of similar. It's a similar story there where give me a minute. They provide some more kind of data, and again something to do with signaling, some kind of phospho signaling in adipocytes. I don't really care. The point is that if you look at the difference between control and myostatin plus trillinidase alpha, then if you're looking at the control, which I believe is the analog to real conditions, human in vivo conditions, and you compare myostatin T alpha and just T alpha with these with the black line, you really don't see, right? So you don't see, these are all in, these are really all the same, maybe slightly higher, so the only thing that they're doing is blocking this excess myostatin here from causing an increase, right? So I guess maybe if someone has an excess of myostatin, which is causing them to gain a lot of weight and lose a lot of muscle mass, then this thing here could potentially be much more effective for them. But nevertheless, the whole mechanism is incredibly dubious, and it's really, really dubious. So I think it's highly unlikely that the proposed method for the in vitro study will translate to human in vivo results. This is the assay that we talked about. Myostatin is weakly bound, which is to say that it's very likely that the concentrations in vivo it's going to be overpowered by adductin. So all in all, this is going to fail. I'm pretty sure this is going to fail. So the question becomes, are there um, other assets enough to offset their failure in Taldef-Groby for SMA, their imminent failure for Taldef-Groby in obesity, their failure for trilesnidase, or whatever it was called, for spinocerebellar ataxia, their recent failure of BHV 7000 for depression. I mean, nobody ever thought that was going to pass anyway. The only things that they mention, at least, that they're going to be working on next are it's this. So if you read their latest press release, we'll be focusing on clinical data for phase 1B expansion, BHV 1400, IgA 1300, exploitation of company recently changed to be studied with Taldef-Groby. Again, this is going to be poo-poo. I'm not sure about their oncology assets and this focal epilepsy study. Interesting that they don't mention anything about that Parkinson's study. Maybe they know something that we don't. I'm going to be looking into their IgN and their BHV, their Graves, their IgN and their Graves' disease solutions soon-ish, preferably before sometime in January. They have I think they're presenting some results at some sort of health conference or another in January. So it'll be good to have a decent thesis by that point. And to be honest, I think the thesis is going to be this thing's probably fairly valued. I mean, 1.4. I mean, unless I can find a reason why these drugs are definitely going to fail or definitely going to succeed, or find a reason why this focal epilepsy thing is definitely going to succeed or definitely going to fail, or why their Parkinson's trial is definitely going to succeed, definitely going to fail. This is just an incredibly risky thing to be short or long. I mean, say that, I shorted. Firstly, I'm not sure that the market's actually pricing in success with this obesity drug. So even if they, well, who knows? I mean, it kind of crashed on depression this morning, but then it rebounded, right? So their depression data, it crashed before Christmas, and then it was back. I think that this obesity result is pretty much priced in. So the question becomes, what's the deal with BHV 1400, BHV 1300, BHV 7000? And if any of those turn out extra juicy, I will be sure to let you all know. But in the meantime, Merry Christmas and Happy New Year, and stay healthy and happy, and hashtag YOLO or something, I don't know. Anyway, goodbye.